the feature below is the size of the ear. So that's two different features, that's two different dimensions, and it creates a plane, you know, a wall, or perhaps a YouTube screen.
Are you still there? To delete this message, press 7. To change the press 9.
How's it going, guys? How is every single darn thing? Because I am happy that you're here. I hope you're happy to be here. Welcome, welcome. If you are new here, it is a pleasure to have you. My name is Andrew. On this channel, we are trying to get you a six-figure salary in 6 months as a data scientist. And no matter what part of the journey you're on, we're gonna bring data science down to earth in the most dissectable, in the most delectable way possible. With comedy, with a bit of spice in the very nice theoretical modeling. And today we are going to finish off the isolation force versus SVM video that we and today we are going to finish off the isolation force versus SVM video that we released a couple weeks ago. And today I want you to do something right before I get started. I want you to like this video. Give it a big old like, because that is a way that I can continue making content for you by defeating that evil YouTube algorithm. And the other thing that I'm hoping for is that you, a person who is new here, has already subscribed, because that way you will be able to keep up and stay up to date with the best data science industry education you could possibly receive. So with that, and a big thanks to Kenji, Data Professor, and everyone who has supported the channel so far, let's get started. Today we're going to talk about the support vector machine, and what you're looking at in this animation is what I am going to explain to you very soon. Now, this animation was not created by me, as much as I would love. We are going to put the actual credits to the people who made this animation down below, but it truly is a beautiful visualization, and if you are not quite sure what it means, we are going to get there. Don't worry. But let's start like we always start. Let's start where we always start. Let's start with a furry example. This furry example involves a two-dimensional feature space. Whoa, did I lose you yet? Hopefully not. This is a feature space, whether you've seen one before or not. We have a feature on the left side, which is the amount of indoorness or outdoorness, and on the bottom we have another feature. The feature below is the size of the ear. So that's two different features, that's two different dimensions, and it creates a plane, you know, a wall, or perhaps a YouTube screen. So what we're looking at here is cats on the right side, because they seem to have smaller ears and they usually are indoors, and dogs on the left side, because they usually have larger ears and they're usually outdoors. Now this allows us to very handily draw a line right between them. Okay, so are we done? No, we're not done yet, because this is just a guess. This is a good guess, let's say, but we have to make sure this is the best way to separate the dogs from the cats. That way, when new cats and dogs pictures come in, we want to be able to use this line and definitively say, hey, because of our training data, because of the line we drew, we are very certain this is a dog or this is a cat. So we need to draw some vectors. And this red vector that I've drawn here and here and here would be able to simulate the distance to the closest point that we're trying to separate from the dogs and the cats. Something like this black and white cat over here, or this little golden cat right there, and of course this little dog that looks like a cat, and this little dog that looks like a cat. If you don't think these dogs look like cats, you might be right, and I just don't know what dogs look like. But if you agree with me that these dogs and cats are on the fringe, that is what the support vector machine model is looking for. These vectors are supporting the model itself. The red lines are trying to support the line of best separation by creating this gray zone of neutrality. This is how the model grades how good of a job it's doing. You see, the larger the gray area, the better job it does. So if this line was slightly askew to the left or the right, that gray area would be smaller because it no longer becomes such a good line of fit. The vectors, the red lines, are going to be smaller. So if we maximize the size of the vectors, we maximize the size of the gray area, and that way we are supporting our model and the vectors are supporting it. I support vector machines, don't you? Vector Machines 2020. Let's continue on with more visualization. So as you can see here, we have that neutral zone that we talked about before. So that's what we're trying to maximize. But let's move forward and look about errors. Errors are when you classify a dog as a cat or a cat as a dog. Now, when you're talking about animals, it doesn't seem that malicious to have an error, but you can actually do a very big boo-boo doo-doo by misclassifying a fraudster, someone who uses your credit card in Tahiti and buys a lot of Thousand Island dressing is looking pretty suspicious, and we don't want to accidentally mislabel him as a normal transaction. At the same time, if you end up using a card you haven't used in a long time in a different state, it might be a little bothersome to have to do a two-factor authorization or receive some sort of text from your credit card company confirming that it's you, but that little extra line of security, that misclassification as your normal transaction as a fraudulent transaction, that's a small price to pay compared to the big price of letting a fraudster through. So it really depends on how you want to grade your errors. And luckily, we do have a parameter, a hyperparameter we can insert into the model that tells us how are we going to measure errors. How many errors can we even allow? That's C. C is a value that as it rises, it makes it so that we can accept fewer and fewer errors. So we see when C equals 0.01, then the gray area is a lot larger than before. That is good. We want to maximize that neutral zone, but we do have a lot more errors on our hands. You see, this neutral zone here gradually decreases as we increase C. That way, we are a lot more careful with what we consider a dog and a cat. If that's a little too technical, or maybe not technical enough, you can comment down below and tell me exactly what you are hoping to get out of this lecture, and we can make it into a brown bag live stream if you want to ask me more questions in person. But I'll always answer a comment down below. You guys know this. And let me take this as a moment to say, have you checked out a Data Leap authentic playlist? We have many playlists from DIS for data. We have 2 minutes of Python. We have the Cracking the Data Science interview live, and we have the how to make 6 figures as a data scientist. These are all playlists that I'm going to link below, and you can try them out to have a streamlined experience in becoming a data scientist today. Now, let's continue. So, what if we cannot separate these two? Well, that's kind of problematic, but not so much if we think about it, because where there is a plane, there is a way. This is a plane, a two-dimensional feature space, a two-dimensional plane, but what if we can bring into the third dimension, a three-dimensional feature space? Then we can cut it with a plane, a second-dimensional slice through that three-dimensional space. So what we're visualizing on the left side is this curvilicious, asymptotic looking dual line on the right side. You see this animation that we see over here on the left is actually, in some way, if we overlay it correctly, going to look the same as the picture on the right. That's kind of funky, right? Just to prove it, in case you don't believe me, we're going to add that gray zone of neutrality. And you see on the left visualization that that gray zone exists separating the closest red point and the closest green point. That's beautiful. I love visualizations. And that is the crux of a support vector machine. Now, in the last video, Isolation Forest, I was going to rate these two models on explainability and trainability. But explainability is going to be based on what you guys think. And personally, I think that these two are both very explainable. There's an easy way to tell exactly which features are being regressed most heavily and which data points are affecting the model the most, the data points that are closest to that line of delineation, that line of separation. Now, this model involves finding an optimal solution, not a random one. So therefore, it trains a lot slower. It takes a lot more training time than the random isolation forest. And it actually performs better when you have less information. Of course, it has to be a randomly sampled representative sample of your population. Of course, that might just contribute to it being more overzealous and more underfitting a specific type of population, depending on what you're looking for. That's where the random isolation forest comes in. You see, it's random, so it'll always have a very similar runtime. And the more data that the isolation forest gets, the more specific it gets and the better it performs. That is not the case in the support vector machine, where it has to really make curvilicious paths for every specific snowflake of a data point. And that might be troublesome for your model. So, how did I do in terms of trainability and explainability? Well, you can grade me down below in the comments section. And speaking of the comments section, let me head down there and read some comments that really warm me to the bottom of my heart. If you got this far into the video, give yourself a big old pat in the back, because I want you to know I appreciate you and I want you to subscribe. Yes, subscribe. I have amazing content like collaborations with Data Professor on the $0 Data Science Bible, first 21 days that you should be spending on data science. And of course, that goes hand in hand with the 66 days of data that Kenji has been championing for a long time, at least a week or two at this point. But there's a Discord server with hundreds of people from all over the world. And if you want to be part of that community, it's never too late to start your 66 days of data. Thanks, Kenji. Speaking of Ken, I just finished a collaboration with him that I released on my channel and he released on his channel. We cover my story from hedge fund to FANG company, and we cover Ken's take on his path as a data scientist and a couple of funny, alluring, seductive questions. Flynn Rider does it when he goes like,
Oh yeah.
that you might just find pretty interesting. Of course, if you have not met me yet, I have a 2-minute trailer on my channel talking about how you can become a 6-figure data scientist, where I destroy my smartphone. Hey, I'll see you when we leap.
You just have to say that you're fine when you're not really fine, but you just...
And it is as funny as you think, and it was a lot of fun to make. So, if you like this video, please give it a like. If any of this content sounds interesting to you, please hit that subscribe button and hit that bell button so you're notified every time I upload or do a live stream, because that is a good opportunity for a small creator like myself to get to know the community itself. I'm starting a new series about the community where I do small one-on-ones with the people that comment and react and are part of this community, engaging and trying to become a data scientist. And I'm of course going to upload a couple of smaller skits and sketches about living in the Bay Area and how to become a Silicon Valley data scientist here. That's a lot of editing for me. Let's head on to the comment section. You guys stay awesome. Peace. This comment came from Discord from one Aaron Petrie or Petri. I now set my schedule to when Andrew from Data Leap goes live. Link for anyone else. Thank you, Aaron, so much. That touched my heart. That's honestly so rewarding to hear. I don't need anything else all week. Thank you, Aaron. This is also from Discord, from a Mr. Shubhamai. Of course, I will butcher your name for fun and for profit if you want me to. Oh, I didn't notice the moment you actually fell into the pool. We leap. There is some real dedication to make YouTube video. Hey, Shabumai, you're the real hero here. Thank you for engaging with that video, and I'm glad I could brighten your day with stepping into the pool. On Discord, I said, hey guys, I had the pleasure of answering Dominique James' question on how to introduce a daily plan to data science and create a top-notch superhuman data scientist from scratch. The video link goes directly to answering this question. If you want to be featured in the next video, message me directly or leave a comment. That offer still stands. Aaron replied, same Aaron as before, great video, very informative, but did have me questioning alternate realities and timelines. Dom actually responded, and he said, you're a boss, smooth like gloss, pure like silver in furnace, no dross.
Oh yeah.
Get this man to a publisher ASAP. And then he said, thanks for responding to my question, for a friend. Ashley B follows up and says, can I be that friend or what? But seriously, great video. Dom continues the conversation and says, we can both be that friend, Ashley. I might be jumping on Kaggle since Andrew from Data Leap made the recommendation. This was wholesome as heck, and I said, you guys are making my day. Ashley says, do it. I'm working on the Python micro course today. Let's hold each other accountable. And then Dom says, what lesson are you on? Connections being made every day. If you want community like this, let me know so I can add you to the Discord. On YouTube, on the video Forbidden to Ask This in Tech Interviews featuring Kenji, Ravi Kiran says, just subscribe to this amazing channel, waiting for good content, lots of love. You're the man, Ravi. Won't let you down. Calvin Pinto is back on the video, learn all of Python in 10 minutes, with if Professor Meatball would teach in my college, he would surely complete the entire data science syllabus in a week. Truly, how is he so accomplished? He does have a doctorate. On the same video, Andrew Jaffe says, great explanation all around. Can't believe you actually managed to keep it at 10 minutes on the dot. That is a time doctor's secret. Two Bros says, wow, I wish Professor Meatball was my computer sci professor. Me too, if only. And Joe Galong says, this was basically the entire MIT X Python course in 10 minutes. Wow. Wow indeed. In fact, wow for you for staying all the way to the end. If you want a copy of my resume template and you still haven't gotten it yet, I think I have maybe 20 more, and now's your chance to grab them. I'll link to the video that tells you how, and if you're not having a good day, tell me why, because I want you to have a good one. That's it for now. More data science on the way. Peace.
Are you still there? To delete this message, press 7. To save it in the archives, press 9. To hear more options, press 0.
What are you talking about?